Good afternoon and welcome back to the next video in the series on making a circuit board at home from your own design or one you've scanned or whatever. So this part will deal with the stuff. What am I saying? This will deal with the task of cutting out the board from a larger piece if necessary, and also with cleaning the board, which is often also needed, so your etch resist can apply cleanly and doesn't fall off halfway through etching, which is never a good thing. Alright, so first thing I would say to do obviously is to, well, maybe not obviously, but the first thing I would say to do is to print out your artwork on a plain piece of paper. Now this one is for the power supply that I want to build, which is from this kit, well, rebuild from a unit that I bought second hand and would like to rebuild. It doesn't have the circuit board or the transformer, which I'm going to do that. I've got the transformer, I've bought that from JCar, and I need to get the board, so I need to make this myself basically. There's no really other way of doing it. Anyway, that's beside the point. Like I said, first of all, print this out on a piece of paper, plain paper, and you want to check the dimensions are actually correct. So in this manual, for example, it says that the board measures 149 by 113 millimeters. So get your rule or whatever and measure the board, measure the printed artwork that you've done, and have a look. So this one, for example, I'm just measuring inside the corners of these registration marks here because that's the actual dimensions of the board. And that gives me 148.5, and this gives me 114, which is pretty much accurate. I mean, obviously not exactly what they said on the manual, but for something like this, it only uses through-hole parts. It's very large clearances, no tight tolerances or anything here, so you know, a small margin of error, 1 or 2% or so, is not a problem. This is basically a direct copy of what they had printed in the magazine article, so yeah, maybe there was a scaling issue with the original image. I didn't change any of the scaling in mine unless there was an error introduced by my scanner or my scanning software. But this, the dimensions of this were the same inside Inkscape when I scanned it, so it wasn't my printer that made it slightly larger, it was the possibly the scanner, or it was just printed like that to begin with. But in any case, that is something you definitely want to check, especially if you have a small board, a tightly packed board, you're using fine surface pitch components, fine pitch surface mount components, or anything like that, or you've got traces running right next to the edge of the board. Anything with tight tolerances and that kind of thing. So you want to make sure that everything makes sense, especially with the fine pitch components, as I said, because if there is a scaling error and it's, you know, above 2-3%, it is possible that you'll get an error and a problem, and you may actually be unable to solder the components on properly because the pin spacing might have gone out of whack. Unlikely, I suppose, in most cases, but definitely worth looking at because it can be a problem if you're unlucky. And the printer itself, the printer driver, your graphics programs, your operating system even maybe, your scanner, whatever, they can all cause small errors. So basically, yeah, it's a great idea to just print the image out as is on a piece of paper, measure everything, check the spacing, and then adjust as necessary in your graphics program or in your printer driver, or whatever, if there is a significant error that may cause a problem. Anyway, so enough about that though. And now that we actually have the thing checked out, and like I said, it's pretty much fine. It's definitely very minimal error for a board this basic. I say basic, but I mean, you know, with large tolerances, there's no need to get that precise, so that will be perfectly fine. So anyway, once you've checked that, obviously you want to get your blank circuit board material. Now this particular one here is well, there's sort of two main types you can get, although this isn't really about that, but you can get FR4, if you've probably heard of that. That's a fiberglass based board material, and then you can get other cheaper stuff which is based on paper based phenolic bonded resin, that sort of stuff. Or is it, sorry, synthetic, SRPB, synthetic resin bonded paper, SRBP, yes, that's the one. That's, I think, what this is. I'm not entirely certain. I bought this second hand, and it's probably from the 70s maybe, or 80s. It's marked BXL, which I'm not entirely certain where it came from, but it's pretty old, as you can tell by the way the copper is tarnished. And it's yeah, it's the old brown style stuff that you find in old equipment. And you can't really buy this anymore, I don't think, at least not brand new anyway. Most shops will sell you the FR4 stuff, the fiberglass stuff, but you can also buy newer versions of this, I think, on eBay from China if you want to be if you want that particular type. I think they often call it G10 or FR2, but again, it's with China eBay stuff, it's sort of not guaranteed exactly what you're going to get. Not that I've actually bought any on eBay yet. They've pretty much had a decent supply of stuff that I've been using so far, but I am starting to run out, so I will be looking at that in the future for my next purchase of blank material, I suspect. I know at least in New Zealand JCar sells pretty good sheets of FR4 material, which is 300 by 300 millimeters, which is bigger than this, so it's nice 300 mil square. I think it's about $25 for that, single-sided, which is not bad, but you can probably get a slightly cheaper one. eBay do 300. I think the largest size I've found from China was 300 by 200, which would be about to here, and that's 200. So it would be slightly larger than this, about the size of an A4 sheet, really. And you can buy that for a fairly decent price too, with free shipping probably worldwide. So yeah, just in comparison with that, the eBay stuff is a little bit bigger and not too bad. Anyway, so that's kind of going off track again, isn't it? What I'm supposed to be doing is cutting this board. So, like I said, we've got the dimensions of this. It's supposed to be 149 by 113, and like I said, this is 114, so we'll go with that because that's good enough. So measuring the thing here, now I'm going to cut this a little bit bigger. I'm going to do 151, and the reason for that will be because the edge doesn't always cut cleanly, depending on the method you're using, and so you need to sometimes sand it down or file it down. And if you do need to do that, obviously you'll need to have it a little bit bigger to start with. So measure your thing, get everything figured out, and take a pencil or whatever and draw a nice line so that you can see what you're doing. And there we go. So I'll want to cut that here, and obviously also I'll need to cut a piece across here because that'll be too wide otherwise. Now it's worth noting on this one that there are some pre-drilled holes in it. Like I said, this was second hand, possibly surplus from production. They may have been alignment holes to align, stacks of boards for multiple drilling and cutting at the same time. So another thing obviously is you want to take this artwork, lay it on here, check that the hole is not going to interfere with anything, or if it is, it'll be a workaround. In my case, that's not a problem, so I don't have to worry about it. But I shall Obviously, in most cases, probably no one really needs to worry about that, because you probably won't be buying second-hand surplus boards with holes in them. But if you do, obviously take that into account and make sure that it's not going to be a problem. Anyway, so obviously mark it out, that's obvious, and then you need to cut it somehow. So there's various options for doing that. Now the first thing that comes to mind is to grab a hacksaw and go at it like this, which is quite terrible, because you will often end up, well, inevitably end up with a horribly squiggly line and a really horrible edge which will just look awful, and it'll work, but if you're trying to go for any sort of precision, it's terrible, and you'll probably have to do a lot of sanding to clean it up, and it's just not that great. So that's not the best idea. If you do want to use a hacksaw though, a better option to do that is to, I'm obviously not going to do it here, but what you would do is set the board on something and clamp down some sort of straight edge to the board, and then cut this way. This will be a bit slower and a bit trickier to start off with, but you will obviously get an actual straight cut rather than some sort of wobbly thing that wends its way down the line and doesn't actually fit on it. That's one way of doing it. You can use some kind of table saw with a abrasive disc attachment or cutter designed for this kind of thing. I haven't done that myself, but some people do. Another option is a tile cutter. Some people find those to be quite good. I personally haven't tried that myself. Another one is to use tin snips. This is a pair of crusty old tin snips, and you just cut it as you would a piece of tin. Now, for this particular stuff, I wouldn't do that because this phenolic stuff is very prone to cracking, especially if you do this sort of thing to it. So only use these on fiberglass board, not the phenolic stuff, because you'll probably just crack a big chunk out of it and then you've wasted a piece of board. So anyway, I can't demonstrate that obviously, but yeah, that's one thing. Obviously this will, maybe not obviously, but if you're cutting fiberglass with these, they will get blunt pretty quickly, and so you'll need to either use some old crusty ones you don't care about, or sharpen them often and all that. Well, you'll probably have to sharpen them anyway if you actually want to use them to cut the stuff with. But yeah, right, so there is a another option if you have the money, is to buy a guillotine or some sort of cut-off machine. You may already have one. Obviously a guillotine for paper probably won't work. Again, it will get blunted quite fast from the fiberglass if that's what you're cutting. But you can buy special PCB guillotines that are designed for this. They have hardened blades, and the only problem is they're quite expensive. So again, unless you're going to start doing a whole lot of stuff, it's not really worth the bother. But this is more aimed towards the one-off random hobbyist sort of thing, so we want to go with something that's quick and easy and cheap. And probably for this particular material, and as well as for fiberglass stuff, but for this one particularly, the probably cheapest and easiest way is just to use a knife. No, not to cut it like this with a knife, but you kind of do it like you would when you're cutting glass, and then as you score a nice line on that side and score a nice line on the other side, and then you can just snap it in half. So that's what I'm going to do with this, because that's the easiest way to do it for this particular thing. So oh yes, there's one other option. If you have a milling machine or a drill press you don't care about, you can load in a cutting bit or milling bit. Well, probably not a milling bit, but a cutting bit. You can get those on eBay pretty cheaply if you're doing that, and you can just use that as a cutter. Like I said, if you're using a drill press, make sure it's one that's cheap or you don't care about, because the radial load on the side of the bearings will wear them out pretty quickly, as well as the fiberglass dust probably getting into them. So use some sort of extraction device like a vacuum cleaner if you're doing that. And also don't breathe the dust too much, because you'll probably get some sort of lung disease. Yes, anyway, so where was I? Yes, if you have access to that, that's an option. That will give you a very nice clean cut if you are able to do that. But I cannot do that with my little Dremel style thing, my Proxon tool and its little drill stand, because I believe this will be too wide to fit under it. So I'll have to use the score and snap method anyway, which is why I was going to show that. So that's fairly obvious how that works, so that's what I'll proceed to do. And I'll just get a piece of cardboard here to make sure that the knife doesn't end up wrecking my anti-static mat, and we can just put this on here. So that's quite simple. In terms of a knife, well, if it's sharp enough you can use anything, but I would advise to use a Stanley knife with replaceable blades, because this will obviously get them blunt quite quickly. Unless you want to sharpen your knife every 5 minutes, especially if you're cutting FR4 this way. Although I wouldn't recommend using this method to cut FR4, because even though it will work, you will have to do a really deep cut, deep score on both sides to get a clean break. Otherwise you do risk sort of tearing the inner layers of fiberglass, because they weave it in multiple layers in both directions, and if you don't score deep enough it'll sort of tear on the edge and you'll have to file a bit off, which is, again, this is why I say you should make sure the board is initially cut slightly bigger if you can than what you actually need, just in case something like that happens, and then you can clean it up with sandpaper or file or whatever afterwards. There we go. That should be deep enough. And now if we turn it over, do the same on the other side. Just make a mark there so I can see what I'm doing. Actually, I should measure it. I said 151. No, it wasn't. That was the other direction. We want 115. And it would be great if I had a set square for this, but that's alright. This is good enough. Like I said, it doesn't matter if it's a little bit rough or a little bit wrong. We can always sand it down later. And even this, it doesn't really matter, because there's no real need to have it the correct size. There's a lot of room in the case, and if it's slightly wider or slightly longer, it won't really be an issue. Anyway, this is fairly easy stuff to cut, so that should be good enough. Now that I've got little bits of fibre everywhere. Anyway, at this point I can probably just break it with my hand, but to make sure the cut is straight, I'll stick it on the side of this bit of wood. Should do it. No, actually I'll use the side of the table. And then you just need to stick it on the side of a straight edge or something, and just snap it off like that. As you can see, that's worked pretty well, although I did make a slight misalignment of the two cuts, so I will need to sand that down, but that's not a problem. Like I said, there's enough space, it's all good. Anyway, and we can just do the same thing for the bit on this side. So, let's see. That needs to be... That was the... yes, 149. 149. And this is where the bit of wood will come in handy. So I can line that up on the end of the wood. You should be able to go like this. And there we go. Comes right off. And we can, and now we have the board cut to the approximate right size. So I'll just need to sand these rough edges down a bit, and all that, and that should be fine. So, obviously the next step then is to clean the board up, and the best way to do that, well, there are multiple ways to do that, but I personally use sandpaper. For a light tarnishing like this, 400 grit is usually fine. You don't want to get too heavy, otherwise you risk rubbing the copper right off the board and then it becomes useless. But if you do have heavily oxidized copper or something like that, then you can use 150 grit or 200. 300 might be alright, but I go to 150 if I want to do a good a really good clean, but again that's usually unnecessary because the 400 should usually suffice. Alright, so here's some bit of old sandpaper. Looks a bit crusty, but there you go. So you can just take that. Like I said, this is the 400 stuff, and you can just start sanding this down. I won't do the whole thing because I usually like to do it wet, but just to prove the point, you know, just take this. And you should be able to see how that cleans up really quickly. This one does have slight pitting in general, probably because it is quite old. So I will probably use this coarser stuff to file that down a bit more, but there we go. I mean, that's very easy to do and doesn't take very long at all. But yes, you do need to make sure the board is clean to some extent before you actually apply your etch resist, otherwise it won't take very well, and like I said, you're liable to get the etchant going under the etch resist, you get undercutting, you get problems, and it just won't work very well. So what I'm going to do now is I'm going to go and sand this off completely off camera, and I'm going to come back and do that. Okay, so I've just finished cleaning the board up, and here we go. Here's the cleaned version, and you can see it's a lot shinier than it was before. It's definitely a lot shinier than the piece it came from, and we can see this is actually the front. This is indeed the copper side. That's the back side with the logo on it. This is the front. There's a big difference, and you can see obviously that this one is much cleaner, and that will definitely help the etch resist stay on and not fall off and not cause problems. So you definitely do want to clean it, especially if it's like this and it's been sitting around for 30 years and it's got quite a patina on it. Anyway, so I did have to use the 150 grit sandpaper on this, which I used to get down most of the old oxidized copper, and then I finished it off with 200 just to keep it nice and smooth. You don't want too many deep gouges in it for the etchant to run in under the resist with. Anyway, also worth noting to make sure you sand the edges down as well around here, because after you cut it, there's generally sort of a rough edge of copper, and that will cause problems when you're applying the resist. It will could cause problems around the edges with the raised edges, won't let the resist adhere properly or whatever, so you want to make sure that's nice and smoothed down also, so you maybe don't cut your finger on it either. Sand the edges, sand all the stuff around here, and just make sure it's all nice and cleaned up well. So that's what I've done, and it's now pretty much good to go. So basically I used the sandpaper wet with water. You can use wet and dry sandpaper so it doesn't disintegrate, and yeah, I just rinsed it off after sanding finished, and then dried it with a paper towel, and after that point just make sure you handle it by the edges. If you get your finger oiled on it, it will cause oxidization, corrosion again slightly, and you'll have to clean it again before you put your etch resist on. But yeah, as long as you don't handle it or get anything on it, it'll stay like this for quite a while, so I can easily leave this for several weeks before I apply the resist. But obviously if you leave it for several decades or whatever, it'll go like that, and then you need to clean it again. But most of you probably won't have that problem. So, but yeah, just worth noting that you don't need to apply the resist immediately. You can leave this lying around for a few days or a few weeks. Won't be too much of an issue, but after some time obviously it will start to oxidize to the point where you will have to clean it again. But yeah, anyway, so that's that. Yes, we can also check, I suppose, if you want to be really paranoid, to check that the board is in fact the right size for the artwork, which I can line it up on here. And I can see that it is pretty much perfect. It's slightly wider by a little bit because I didn't have to sand this edge down as much, because the error that I made when cutting it wasn't as bad as on this edge. So the this dimension, the height is pretty much perfect, and the width is slightly too big, but you know, like I said, it's 0.5 millimeter too wide, and that's not going to be an issue because there's tons of room in the case for this and it won't be a problem. So really this thing is perfectly good. So that's this for this one. I'll come back for the third video when I show you how to get the artwork from paper, from computer. Well, so from computer so that it's not on paper but actually on the board. And I'll demonstrate how to do that. But that's about it for this one, so I'll see you next time.